just a starting. Okay. This is about the inverse. Okay, just to confirm and just to want to make sure that we are on the same page on what is the inverse. Okay. What is one-to-one function?
That each value x gets one value of.
Yes, yes. But how do we know visually that the function is one-to-one? Yes, yes. So one-to-one function, we could remember easily. Okay. Horizontal test, right? Horizontal line. It means that if we take the curve like that, and we take the horizontal test like this, if it is crossing the curve only once, it means that it is one-to-one function. What's the implication? What's the implication of one-to-one function? Is that that function has an inverse. Okay. I think you could also can get the understanding of the inverse from the graph. Okay. So if I graph, maybe let me graph again, maybe different kind of function. Maybe let me graph. Let's say we have maybe this. Okay. So let's say this is f of x. Okay. Another way we can set up the inverse is by taking the y equal x line. Okay. I think I mentioned also in class. But I think I just mentioned like briefly, so let me make sure that we get the same page. So we can also set up, let's say this is y equal x. And our f inverse is basically the mirror part of the f through the y equal x. So this will be the f inverse. Okay, we can set up the inverse like that. Okay. Yeah. So every time you see a graph, and if you would like to know whether, so first you can try the horizontal line. Okay, it's one-to-one function. And then the next thing is if you want to get the inverse easily, you set up the y equal x and then mirror this and okay, this is f inverse. Okay. This is simply changing domain to range and range to domain. Okay. Okay, since we are changing domain and range, then if we look at this number 17, I think if we have f of 6 equals 17, then f inverse of 17 is 6, okay? So f inverse 17 is 6. I think the same way with number b. Okay. Okay, what will be the 18? We have f of x to the power of 5 plus x cubed plus x. Find the f inverse of 3 and then find the f inverse 2. It's tricky. So what will be? Number 18. I will let you think first. Sometimes it's not so easy to get the expression. But this is asking directly, right? So maybe then you don't need to make the expression for the f inverse, right? Okay. The idea is still the same. You have this, then the f inverse is this, right? So if you look at the x with power of 5 plus x cubed plus x, and then we need to get this getting to be 3. Yes. Okay. Do you get it if I answer that the f inverse 3 is 1? Okay, so first, if you look here, so let me write here. Okay. So f of x. Okay. So if I'm asking this, it means that we need to find which x that when we plus or when we plug in that number, it will equal to 3. What will be the number that equal to 3? 1, right? The most possible way. Okay. So by some inspection, by some observation, we know that this should be 1 because F1 is, let me just write this, it's 3. And then by our relations from the number 17, okay, I think it's still okay, right? It's still okay, we get that expression. Okay. Okay. Do you get it? Okay. Students who get low score, do you get it? Okay. Okay. Now the same way for number 19. Okay, the same way for number 19. You get 3 plus x plus e. Okay, now we have e. Okay. So we get e, that is 3 plus x plus e. And you want to have g inverse 4. And remember, when we have this inverse symbols like this doesn't mean 1 over g, okay? I think a few students write 1 over the function. Okay, that's not the question. This is the inverse. So this is the same with the previous question. So what x that I can put here and it's equal to 4? What x? Yeah, what kind of x that when you put here is equal to 4? 0, I think 0 will go there. If 1, you still have e, right? Okay, so it's 0, right? If we put 0, this e to the power of 0 is 1. 1 plus 0 plus 3 is 4. Okay? Okay. We can say that this will be 4. So g inverse 4 is 3. Oh, 0, so it's equal. Okay. Okay. Okay, number 20. We have the graph. Do you need to write here? It's small. Okay, we have a graph. And then it's asking why is f 1 to 1, we already mentioned. Take the horizontal line and check every point on the curve, and we see that there's only one point that will cross the curve. Okay, it's 1 to 1. So 1 to 1, use horizontal line. Okay. You could write clearly using horizontal line. We get f is 1 to 1. Okay, that's the complete answer. But I just want to write the horizontal line. I hope you get it. Okay, the horizontal line. What are the domain and range of the inverse? Because inverse is exchanging domain and range. The first thing is maybe we could look at domain and range for the function itself. Okay. So how to set up domain? You can just look at the x-axis. How much point or how much interval we have. So from maybe 1, 2, 3, negative 3, right, until 3, right? So we can set up for f. For f, so domain of f is negative 3, 3, right? And then range of f is what? Negative 1, 2, 3, right? So we exchange this. So domain of the f inverse is, and then range of f inverse is this. Okay. And then what is f inverse 2 of 2? Remember we exchange domain and range? So we need to find where is 2. 2 is here, right? So it means that it's going to be 0, right? It's going to be 0. So let me write here. Since f0 is 2, then f inverse of 2 is 0. Okay? From the graph. In the same way, so when we have 0, so we have maybe it's not really clear. So when we have the f inverse equal 0, when f inverse of 0, so we need to find the y value that is 0, which means, or not y, it's x values are here, right? So this, you can use assumption. Okay, maybe this is 1 and 2, so it is closer to -2, maybe -1.8, 0.7 is okay. You can just say assumption. So by looking at the assumption, so maybe we can write also maybe since f maybe 0.7, okay, and is equal 0, so f inverse of 0 is around, or maybe let me write with the approximation like that, because it's not the exact point, right? Okay, so that's inverse by some analytics, visuals. Okay, we have done inverse. Okay, who still get lost, confused? Oh yeah, I forgot to mention number 18. Okay, so number 18, I forgot to mention this one. So this is, let me just write the theorem that if you have A, this will equal to A. Okay. So f of f inverse of 2 will be equal to 2. Okay. I think you could also think, because functions like a machine, right? You put x, you go to f, you get f of x. The inverse is we reverse. Right? We got back and we got x. Okay? Can you imagine that? Or you still have like a problem with your okay? Good? Good? Okay. So actually, mathematics needs good imagination. The more you can visualize some patterns, some logics in your mind, the better result you can have. Mathematics is not about calculation. It's about logic, reasoning, and patterns. I don't mind if you are maybe you get wrong calculation and typo in your exam. Maybe you get like 2 plus 1, and then maybe you get nervous and you write 4. I'm still okay with that, as long as the process in the calculus part is logic and reasonable. Okay, calculation is, I don't mind if you get it wrong, but the calculus part, understanding the concept, that is the most important. Because human error can be happening, right? And it's not your fault. Okay, it's not your fault. Human error needs to be considered as one thing. Okay, that's inverse. Okay, we move to how to find the formula for the inverse. Maybe we don't really need to take all, but let me just pick 1 or 2. Maybe 25. Maybe 27. And maybe maybe 20, maybe 28. 28 is your question, right? No, it's your question or not? I forgot. I think similar to your quiz, right? Maybe number 30. Okay, a little bit complicated, but we could start from number 25. Okay, that's much more simpler. So number 25. You could try first. Okay, number 25. If you want, you can take the picture and you can solve later as a homework if you want to make sure that you get practice. So also one more thing. You need to change your mindset. You are not high school student who usually get into class, get contents, and then okay, teacher says A, okay A. As students in university, you need to have a mindset that is, you need to be responsible for your own actions. So sometimes professor doesn't give you the whole thing, and it means that the professor expected you to find it by yourself. That's university level. But if you are still using high school mindset that just, okay, you are dependent on your teacher, it means that you are going to catch up really a lot of content by yourself. And if you are not realizing that, maybe in the middle of the process you will get lost. You will get lost. So I hope you can also use many resources. Today's you have a lot of resources. You have social media, you have YouTube, you have a lot of content, right? When I was still students, there is no such thing like that. I need to study, go to library, okay? But you can watch some tutorials. And for local students, you can also check some tutorials if you need, like in Chinese, right? I think there's a lot of content, right? You can try to check and then confirm. Okay. So perhaps maybe some English terms you may be not sure. You can check the Chinese terms for that. Okay. I think I also mentioned that one website that is good for basics is called let me write here. You can check this. It's called Khan Academy. I think it's really good for basic. But of course, if you need more practice, you need to add more resources. This Khan Academy, I think it's best for basic, for foundation. You can check that out. Okay. Anyone know? Anyone have checked this one? Check. It has creating content since I was still a student. So I also watched this content when I was also young. But that time it's still not really good UI platform. But now I think it's already okay. You can have like a small pre-test or small quizzes inside this website to get to know like whether you understand the concept or not. Okay, try number 25. What is the inverse? Okay, the first thing, what's the idea? How to take the inverse? Anyone know? You know? You don't know? But when you said high school, do you get the teacher meetings? Do you get it? Can you try? Try. Do you get it when you're in high school? Yeah. You get the concept. Okay. It is so simple.
I wrote all
Yeah,
this.
you need to calm your mind. Okay, so anyone got it? Okay. Okay, let me help you, okay? Let me help you. So number 25, let me write on maybe here. So let me write here. So gx 2 plus square root x plus 1 Of course, if you see these functions, like if you have like square root, okay, so assumption for the inverse to make this one-to-one, sometimes we need to restrict the domain, but I think this one needs to be having inside this square root need to be at least zero, zero to positive. So first, the technique is, let's take this as y. So what we are going to do, we are going to solve and then solve for x, okay? So x is inside the square root. So what we need to do first. If you are doing square this, you will get into trouble because when you square this part, you will get component that has this. Like a square, this is 4 plus 2, 4 square root this, and then plus this square. Right? So the best way to do it is move to the left, and then you can have a perfect square root that you can remove easily. Okay, so that's the idea. So move this to here. So y minus 2. Let me sit down. Yeah, and then this will be square root of x plus 1. And then we can easily square this too. So this will be y minus 2 squared. Yes? Yeah? Anyone asking? Oh, no. So this will be x plus 1. And let's just write as it is, okay? So x is okay. So the f inverse x, we then after we get this solution for x, we are exchanging x and y, and then we can write x as f inverse, and then we are having x minus 2 squared minus 1. How do we know that this is true? How do we know that this is true? I think for some functions, you could immediately check. For example, I can show you that if you have the, for example, the, let's say you have the x squared, okay? We have the x squared. What is the x inverse? Yeah, square root of x. Okay. You can think like you get the y, and then you take this and make that, and then x, or the f inverse, is square root of x. Okay. And how to make it? Or how to make sure? You can draw from this. I think this one, it's easy to solve. You could draw this x squared like that, square root of x like that, and you can draw the y equal x, and it's perfectly mirrored. That means it's inverse. Okay, got it? And of course, the assumption this x squared is 1 to 1, because if you look at the x squared, and you take horizontal, it's not 1 to 1, right? So we need to assume that it is 1 to 1. So we need to maybe just one side. Okay. And then the same thing for this part here. You get square root. So you are expecting the inverse will have something to do with the square. Okay, that's the idea. So if something happened here that is, you cannot recognize what happened here, it means that maybe at the middle of the step, maybe you have a wrong process. Remember, in my exam, I'll always prepare a good process, which means that when you have like a really long written process, either maybe you'll get something wrong, either wrong assumption or maybe wrong calculations also, that you can maybe make it like really long. Or maybe you get lost. So my suggestion, if you are having that kind of moment, stop the question first, go for the other questions. If not, then you will get stuck for most of the time. Okay. Get to the other questions and try to optimize yourself. Try to optimize. You know your own value, right? I mean, what knowledge you have, you know. You can read the question first and then tackle the one that you think, I can handle this. So do not like, okay, I will start from number 1, number 2. If for number 1 you get stuck, and then 15 minutes, 20 minutes, 30 minutes, you get waste your time, right? So just get out and then number 2. Or maybe you can read first and then tackle which one you're going to answer first. Maybe from the last number. If you write not in order in the answer sheet, that's okay. As long as you number the questions. Okay? That's okay. Okay, that's number 25. How about 27? Okay, now we are increasing the difficulty. Now we have the exponent. E to the power of something. Okay. The idea is still the same. We are going to solve for x, right? But how do we solve this x? How to get this 1 minus x to get down? How? How to get down? Okay, maybe you are not familiar with this. That's okay.
Maybe natural number.
Yes. Take the log or ln. If we take ln, so okay, one more thing. In mathematics, we need to express something, need to be reasonable. Okay. For example, if I take, let's say this is y equal e with power of 1 minus x. If I take log, maybe natural log on the left side, I also need to take natural log on the right side. Because if we put on the left, why would we do that? It's already different expression, right? So if we did on the left, and we also did on the right. Okay. The same thing when you try to rationalize your limits. Okay? If you multiply and then you are not having the other denominator, then you change the function. So don't do that. So left, right, okay. And what's happening when we have log? This 1 minus x getting down. If you're really not familiar and got confused about this, then you will get the lesson in full detail I think on basic of math. Okay. But for now, let me just tell you that when we have this, because the ln is actually log base e, right? Which means that it can cancel. So we can have this term here. Or if you have maybe not ln, but if you have any log here, you can move this power in the front. Okay. So we can write ln y and then becomes 1 minus x. And then what about ln e? Ln e is just 1. Okay. Remember that log e is equal 1. Okay. Now what next? What next is we are getting x equal to 1 minus ln y. And then exchange this part, we get f inverse x 1 minus ln x. And then how do we know that this is confirmed? Again, there are some functions that are easy to be proved. Like the previous one is x squared and the square of x. The other one is if you have e, any exponent with power of x. The inverse is the log. Okay. So if you have e, the inverse is always the ln. And how to prove that? You can prove maybe using the graphics. E going up and ln going up, and it's mirrored perfectly in the y equal x. Okay. Okay, that's the first one. Okay, I think I will leave number 30 for you. Try your best. Find this inverse. Okay. I think we need to move on to another lecture. I think I also leave this part to you so you could just take picture and then you can solve by your own. But the idea for the graph is take the y equal x and then draw the mirror, draw its mirror. And same with this one, take this one, so you have like that, right? You have like that, okay? Okay. Okay, I think we go to the next part. Okay. So, you have any like feedbacks? Not feedbacks, maybe if you feel you are confused on some part, let me know immediately. Because if you think you know, but you don't know, that will be a real problem. Real problem for you, I mean. Because I need to know like how much you learn, Okay. Okay, let's move to the next part. Okay, let me check. Okay, this is I think still in the chapter 1. And I think this is also similar, log and exponent. I think you can take the picture first and try later, and also try finding this domain and range. I think I also mentioned in class, so you could try it yourself. Okay? I think if needed, I believe for the log and exponent, also for domain and range, I will review one more time in basic of math. In basic of math, we haven't yet really discussed much on logarithm and exponent, right? So I think we can cover that on basic math. So you can take a picture first and then try your best to solve, okay? Okay, we are going to move on, and we start from here just to get you the idea of discontinuity and continuity on limit. Okay. Okay, we have a graph G. Okay. State the numbers at which G is discontinuous and explain why. Okay, you have this graph. So maybe we can start from the left, from the negative x, right? So what number that is discontinuous? Negative 2, okay. You see the whole, okay. And then negative 1, okay, because yeah, it acts as an infinite or vertical asymptote. You can say vertical asymptote. And then what else? 0, yes, because it has a gap. We have a jump discontinuity, right? And then what else? 1, also the same. Although when f equal 1, we have a value, but they have different limits. Okay, so 1, and then I think that's it, right? Okay, easy, right? So if you feel like equation in math too much for you, and if you think you can draw the function. Maybe it will help you to see what kind of function we have and where will be the functions be discontinuous or which number that it making it discontinuous. So that's discontinuity, and then okay, we move to here. So use definition of continuity and property of limit. I think property of limit is just a limit as usual, but it's asking you to prove or to show the continuity at the given number a. Okay, maybe we can try some numbers. Let me pick the numbers. I think number 13 is too easy. Maybe just number 14.
I mean, do number 13.
Do you want number 13?
Yes.
What's make you think this is difficult?
And can you just go over it? I have to see it to believe it.
Okay. Okay, try number 13. Let me give you 1 to 2 minutes. Try to think how to solve it. Okay, it's asking continuity. So every time the question asks about continuity, two things you need to have: the limit and the value of that function at that point. Two things. Prove that limit exists, and then prove that when we have the point at that function, it also has the same value. Just two, right? Just two. Satisfy those two. Okay. Okay, I think we don't need to have a break, so we can have early finish. Okay, so maybe usually 12:10, right? So maybe 12 we can finish. Okay. So let me explain first what is the requirement for this part. So continuity, let me write here, is you have limit as x approaching a of f of x. This is equal L, and then you have f at a is also L. Okay. It means that this is continuous. Okay, this is requirements. So requirements. Okay. So first, we take the limit first or take the functions. Okay, same. So we can take maybe the limit first. So limit as x approaching a is -1, so write -1, and then 3x squared plus x plus 2 with power of 5. Is there anything wrong with the functions? Any domain that we need to be aware of? I don't think so, right? It's continuous for all domain. So I think we can just direct substitute. Okay. We can just direct substitute. And basically, when we direct substitute, it means it's the same as this function, right? By logic. Okay. So we get limit. Or if you want it to be complete, maybe let me express with the 3x squared and then plus limit again. If you want to see more clearly what the calculation will be, so this will be 3 minus 1 squared plus minus 1 plus 2 with power of 5. This will be equal to 3 plus 1, it's 4. And then, of course, the f, -1, is the same, right? 3 is 4. So by continuity, they are the same, and we say that it's continuous, right? Okay, how about number 17 or 18? So we need to define something, okay? Because we have interval, and then what number that we should take care of. I think first, if you see number 17, you have the x plus x squared x minus 4, and of course you see from the square root, You can see we need to have some domain, right, that related to this function. Each the x minus 4 needs to be at least 0. Right? So that means this interval is true, right? So first, let's say number 17. So we could write for, let's say a that is greater than 4. We need to say that limit we could say limit as x approaching a. Now let me just write with a first. Again, let's say a is in between this interval. So this will be x plus square root of x minus 4. Okay. So we get that this will be equal to, we directly substitute, so a plus square root of a minus 4, which we can see that this is actually the same as the function again. Right? So we need to write f continue at x equal a for every a in this interval. You could also mention that if you take the limit, also you could take the limit from the right of the 4. So when x approaching 4 from the right side, that this will be equal to 4, which is equal to f of 4. Okay. So we can also say it's continue from the right at 4. So f is continue on this interval. So first is look up the questions. Look up the questions. So use the definition of continuity and property of limit. Show the function is continuous at the given interval. So we have interval here. So we have to set up some a that is in between the 4 and the infinite, which means that a should be greater than 4. And we set up some general limit here. And then we take the direct substitution, and then we say that for continuous, this one needs to be equal to the function of a, and which is we can see by its form, and we can find the f of a, right? Okay, now we say that this is continuous, then f continues at x equal a for every a in between this interval. And also, we can also mention, if you want to take only from the one side, let's say we take from the right side of this f of x. So x approaching 4 from the right, we take, basically take it and just take 4 here, and we get that is equal to 4, which is actually the same as our value itself, at the value itself. And we can say that this is continuous from the right, okay, at x equal 4. Okay, we can also say that. I think if you stop up until here, still okay, but if you are mentioning this, then it is more confirming that okay, this continues from the right. And then you can just write as conclusion f is continuous. So the important part of the calculus is not the number like 4 or infinite something. The important part of the calculus is the reason. The reason. So the more you get understanding in calculus, the structure you are going to write will be more precise. Will be more in detail. Okay. Okay, I think the same thing happened with number 18. You can try it yourself. And you could, I think you could have a sense for all these reasons that this 3x plus 6 will have restricted the domain. So that's why we need to have this interval. So we could say the interval may be a is less than -2. And then that will be continuous. And the same way we could say, maybe we can take from one side limit and then see the continuous. Same way. Okay, and I think now the next part is for evaluating the limit. Okay, that I need to catch up for a while. That I prepare a lot of questions here. So maybe we are going to have maybe 3 questions. Start from the first one. Every time you see the limit, what should you do first time? Check. If you get the value, then okay, you can just get the result. It means that the limit is equal when you have the function itself. It means that you can also say it's continuous by itself. Okay, so if you have number 11, so it's just -2, put here, -6, -7 is -13. I think it's quite easy. But the most challenging is when you have something complicated, like maybe number 13 or 15, or maybe 14. We can start looking at that point. As usual, number 13, check the limit. How to check? Just direct substitute. 4 squared, 16 minus 8 minus 8, 0. Well, we have 4 minus 4, 0. 0 over 0. What's that mean? What does that mean? 0 over 0. And what should you do? You could say undefined, or to be precise, not undefined, but indeterminate. Sometimes undefined we can approach like infinite or negative infinite. But for indeterminate, we're not sure. What is that? It's like a different species. So when we have 0 over 0, there's some method that you can think. Let me just give you a shortcut, but just keep in mind, this shortcut will always work, but I hope you still understand the reasoning behind it, okay? So when you have 0 over 0 like this, so there are some, so first, try to factor. Second, if need to be rationalized, rationalize. Third, if it is trigonometry, think of identity of trigonometry, okay? And 4, you have learned the derivative. You can check the logical rule, if you remember logical. Sometimes logical rule helps, sometimes maybe it makes complicated. So I think you can also think some other methods, okay? So I think the best way is, because we can factor it, right? We can factor this. So we can have t minus 4, t plus 8, right? It's correct, right? Minus 4, yeah. And then we can cancel this, okay? So we have t plus 2, so it's 6, okay? So this limit is equal to 6. So remember, in terms of limit, we can cancel this, okay? Don't worry about that. But if you have functions like the number 1 we did in quiz, you cannot do that, okay? That's different thing, okay? Because in one curve, for example, in this t minus 4 as a function, so you have a curve, but you have a hole at this domain. Okay? You have a hole. So different curve, actually. Okay. Same thing here. Factoring right now. Okay. Easy, right? Easy. Anyone still having difficulty factoring quadratic expression? Factoring, okay. Factoring, okay. How about factoring this one? Number 18. Can we do something about this? First we check, okay, 5, here's 0, okay, 0 on the bottom. So 550 plus 45 minus 5, so 45. How much? 25.
50 plus 40.
So this is negative 5, right? Negative 5, negative 45. 50, 5. No, so 0 over 0. So again, 0 over 0. We have different method. But I think if you see any quadratic equation, you need to think on factoring first. So factoring, how to factor this? I think the bottom one easy to factor, right? So this will be x minus 5, x plus 5, right? Okay. How about the top equation? How to factor this? So let me write here and give you some tips, okay? Okay, so this is every time I got confused and I want to make sure, I want to confirm that I'm correct. So I'm making like a small table like this. So you can fill the table. This first two table here, the first column, you can fill in with the number or the components that when you try to multiply this, it will resulting in 2x squared. So the only possible way is x to x or 2x now. So let's say we are having 2x and x. Okay, and do the same thing with the right component. Negative 5. What possible numbers we have? It can be 1, negative 1, or negative 1, 5. Just try any. And just write here first. Okay? Let me just write randomly, maybe this. Okay. And then we cross multiply. Okay. 2x, 5, 10x, and then you add with the other one. So this is negative x. I'm right random, but actually it's true. So 10x minus x is 9. So that's true. So it means that this is the factor. 2x minus 1, x plus 5. Okay. So we get that this is true. Then we can write here 2x minus 1 and then x plus 5. So yeah, now we can check again one more time. Minus 5 here, minus 10, minus 5, minus 10, minus 11, right? Minus 11 over minus 10. So we have 11 over 10. Okay. Okay, what else do we have? Let me check. Okay. Okay, let's try number 24. You feel it's too much for you? Okay. First step. Check. 0, 0, right? Then we can think at least 3 methods: factoring, rationalizing, or in this trigonometry, using trigonometry. Factoring, I don't think we need to factor this. So probably rationalizing. So every time you see a square root for limit, your initiative should be, perhaps this should be rationalizing. But sometimes there are some tricky questions. They usually need to direct substitute. So always check first. And if 0, 0, if it is square root like this, rationalize. Okay. This is like a shortcut. Okay. If you see the question, how to rationalize? Okay. How to rationalize? Rationalize means that we need to remove the square root. So we need to multiply with another component that can remove the square root. The best way to remove this is by taking this expression. So if we are having the a minus b, a plus b, like this. Okay. So the best way to remove this is by taking this a squared minus b squared. So if this is a minus b, we need to multiply with something a plus b. So if we have like something a minus something b here, then we need to multiply with that. But of course, we cannot multiply. So if you have like a mathematical expression like this and you want to multiply with this. Okay, if you want to multiply like this. My question is, why you do that? If you do this, it means that you change the question, you change the function. The only way that reasonably, if you want to multiply, then we need to also write the same things here. Okay? Okay? Get it? Okay. Okay. It means that this is just one, right? Same thing, just one, right? But why do we need to do this? Because we can change this expression on the bottom side. It means that we can make this a squared minus b squared. Okay? So we have x plus 2 becomes squared, so x plus 2, and then minus 4. So x plus 2 minus 4 is easy to comprehend, right? The bottom side. And leave the top equation after this. Do not try, okay, let me suggest you, okay? Some students will do this thing, okay? Okay, we try to multiply this, and then you multiply 2, and then you multiply this, waste of time. Do not multiply like that. Just keep the components as it is. So keep this and keep this, okay? Solve the questions like this, it will helpful. The bottom side is x plus 2 and negative 4. At least, you could see something might happen here. So I think we could solve this, and then maybe let me write the bottom side just x minus 2, okay? Let me write completely x minus 2, okay, agree? So this is x plus 2 minus 4, okay, so we can write that. Do you see something? 2, okay. So what happens when you multiply, like I previously mentioned? If you multiply the top, you wouldn't see this. Okay? And then you'll feel confused. How to solve this, blah, blah, blah. Okay? So you need to get step by step with the correct steps. Okay? Slowly but sure. 2 minus x, x minus 2, we can factor out negative. Okay? Factor out negative. So we can take this x minus 2. And then we can cancel this. So, I forgot to write limit here. So take limit. Limit what is limit? 2, right? 2 plus 2, 4. So it's 2 plus 2 is 4. Okay? Yeah, this is limit. I forgot to write limit. So this will be 4. Okay.
So what about the negative?
Oh yeah, negative. Yeah. Good eye. Okay. Okay, it means that you are paying attention. And that is actually I making me sure. It's minus here. Okay, so this is I'm trying to restructuring your mindset on mathematics because I believe that you study mathematics in a wrong direction before. That I must honestly say that. Okay. Okay.
Let's try another one. Let me give you a little bit complicated one. Try number 31. So for this case, there will be some sort of algebra process in between. But I think the process will be very similar. The difference is maybe something like this, and you need to think what you need to do first. Okay, what's happening if you check this? If you direct circuit with 0?
It's undefined.
Okay, so if we take 0 here, 0 here, so it will be 1 over 0. This is also 1 over 0. Okay, so infinity minus infinity is 0. Who says 0? Okay, let me explain. Infinity is not a number. Okay? Infinity is a concept. If you take infinity minus infinity equals 0, it means you take the infinity as a number. And infinity doesn't work like that. So whenever we have 0 over 0, infinity minus infinity, or perhaps plus infinity, it means that it is also indeterminate forms. Okay? It's going to be indeterminate forms. So this is also indeterminate. We will learn more in details later on about this indeterminate form. But for now, we need to do something with our equations. You see two structures like this. So perhaps we could combine it. That's the thing. Try to combine and look what we have. And try again, check again. If it's still indeterminate, then we need to do something. And I think, for obvious reason, you will still have the square root. The square root means that perhaps we need to rationalize. Okay? Yes, yes, yes. Okay, so anyone solve number 51? Anyone solve? Okay. Okay, number 31. Okay, so first, number 31, we combine the two expressions. So we have a common value at the bottom, that is this, right? And then we multiply and define this is 1, and then minus square root of 1 plus t. Okay, just that, right? And then what else? The top we have 1 and negative here, right? So this is like a, b. So we need to multiply with his friend. Okay, we call his friend. Okay, it's coming now. This is his friend, and don't forget the other friend to make sure that we are correct in the mathematics. So this will become
I think the question is wrong.
Yeah, the question is wrong.
really?
Yeah.
What's the thing I forgot?
Minus 1 over.
Hmm? Okay, maybe you missed something here. So let me explain how I get this. Okay, that's oh right. Okay. So this divide this become here. This divide this become this. This means that we need to have a lot to catch up. Result is, I forgot the result. Let me calculate and then let's see the result. Okay, I forgot the result. I think half or negative half. I forgot. Let's check. Okay, let's check.
Why specifically 1 plus square root of 1 plus 2? Why specifically? Why specifically 1 plus, yes, why specifically 1 plus square root of 1 plus?
You can try it again. Try it again. Try it again. You will see that every time you have 1 minus square,
But aren't you supposed to rationalize it equally?
how do we have
I'm asking.
yeah, you can try it. Try rationalize with this. Try and try to check the result. I mean, if you don't try, you're not getting why we need to have it.
Okay, so this first part, it's 1 minus 1 plus t. And then the second one, we can write. Okay. And then we can cancel 1 and it's negative 1, so we have so t okay, cancel this and then take 0 inside 1 and then 1 plus 1, so it is going to be negative 1 over 2. Okay.
You need to get the same common denominator. We get this. Divide 1. Multiply 1. And then divide this. Square of 1 plus t. And then multiply with 1. So minus.
Okay. I think we spent too much time here. So let's. Okay, I think we need to move
This one? Yeah. You mean from here or from the top? That part? We put 0 here. Right? Okay, easy, right? Zero, okay, 1, 0, 1 plus 1, 2, 1, 2.
Que me digas tú. Lo que quieres.
You mean what kind of ceremony? You mean in exam? No. I think if you can sometimes if you can compete with your mind in this process. It's expected to do that in mind.
Yeah, I would report it.
Okay. Okay, I think one more sections. But I think since we only have a few minutes left, and I would like to have a post test. So let's just do the post test. So for local students, if you want to join, you can join.